Okay, this is a quick tutorial I'm going to do on parallax scrolling in MegaZeux. You could use this in a 2D side-scrolling game. So what I did was I set up a quick little test game to display how this works. So right now I haven't turned on the effect yet, so you can see that it's just a black background. But if I press key T, then suddenly I have my scenery behind the player and behind the board itself, or it appears that it's behind the board itself. It's actually um, using a sprite to draw the board and place it above the scenery, which is sprite 0. So the board sprite is sprite 1. And then I have another sprite, it's actually sprite 231, which is above that, and that appears to, block out the player too, so the player appears behind it. And I can turn it back off again with key T so you can see how this works. So it gives the effect of a scrolling or parallax background. And I'll show you how it works now. Okay, so it's pretty easy. You just basically need to set up a robot, and I put this one here and called it scroll view. And when I press key T, it initializes some sprites. So the scenery is sprite 0. So first of all, it puts an MZM file into the V layer at position 0, 0. Sprite 0 is referenced to the V layer. The X and Y reference are at 0, 0, which is the position in the V layer that the scenery is at. And the width and height is 80 by 25, which is the size of the playing screen. And it is static, so it does not move. So the playing field is sprite 1. I have it set to collision check 2, so it doesn't draw anything that's not, if any characters are blank, it doesn't draw them, basically. So X and Y reference aren't really important. They don't need to be set here because they're going to be set by the program while it's running. Width and height is 80 by 25. And ignore the static. That was something I tried that didn't work. So the foreground is the same as the background. It's collision check 2. X and Y don't actually need to be set. Width and height need to be set to 80 by 25. And then you put in sprite 0, which is the scene sprite, at 0, 0. And you need to set a couple of counters. In this case, I named them screen position and screen position Y. And these are so that when it's drawing the sprite, it knows where to reference the sprites in relation to the player. So the player is actually 40 blocks X over from the top right-hand corner of the screen. So he's 40 blocks over and 12 blocks down. That's what puts the player in the center of the screen. So then I have a loop right here, and this is actually the guts of the program that make the background scenery appear and the board appear over it. So we have a cycle 1 or a wait 1, either works. So you're going to set sprite 1 reference x to playerx minus screen position, which is 40. So it's going to set sprite 1 x reference to where the player is at minus 40, and so it's going to be up here. And then set sprite 1 reference y to player y minus screen position y. That's pretty self-explanatory, I guess. And then it's going to put sprite 1 at same expression here, player x minus screen position, and then player y minus screen position y. And then it's going to do the same thing with Sprite 231. Oh, I didn't explain that. Let me do that real quick. Back out here, actually what the foreground is, instead of using overlay, was I basically created a copy of the board here, and I created it 100 blocks down from the original position right here. So this is 0, 0, and this is 0, 100. And I took out anything I didn't want drawn again. Basically, I want all of this stuff here to appear over the player when he's walking around. Alright, so back inside my program, it's going to set Sprite 231 reference x to Sprite 1x, and then it's going to set Sprite 231 reference y to Sprite 1y plus board height divided by 2. And in this case, the board height is 200. And so I basically split the board in half, and I'm not using the bottom half of the board to physically play on. It's simply there to give some depth to the game. It's going to, that second half of the board is going to just be redrawn over the initial scene, and it's going to appear as a foreground layer, basically an overlay layer. So then it puts Sprite 231 at the same expression as above, player x minus screen position, and then player y minus screen position y. And then I just included this here to be able to turn the sprites off, so I could show you guys that it can be toggled on and off. So that's really all there is to it. You just basically reference a couple of sprites. You want your, basically, I'll go back to the other example here. So if you're looking down from the top, you've got your board, and then your scenery layer, which is Sprite 0, and then Sprite 1, which is again just drawing the board, and then any other sprites you want. And then if you want a foreground sprite, you would have that be above everything else, so you would give it a high number like 255 or whatever you want. If you want to have, you know, a HUD, you would have that be above the above the foreground sprite. And then the overlay appears above everything else. Finally, the overlay is truly the very top layer of everything. The reason I didn't use the overlay in this example is it actually messes up the game. It messes up the scenery, and I'll show you what happens. So if I turn overlay on and I draw something, I'll draw just a quick square here as an example of what happens. Okay, and I'll fill it in. Okay, now I test it, and if I turn it on, it appears to work normal until I move away from it, and you can see that there's a black area there where the overlay was, and I haven't figured out why. I'm sure somebody probably knows why this is, but it basically is just the overlay is cutting off that part of the background scene that it should be, the scene should be drawn over it, but for some reason it's being cut off. So anyway, so yeah, I don't use the overlay for this. Alright, so I went ahead and put in a program that would scroll the background when I moved the player, just to see how it looked. I have the background moving 1 block for every 4 blocks the player moves, and it doesn't look too bad. It still looks a little bit jumpy. I'll show you the program here in a second. Basically, what I did was added set the local counter to playerx, and then at the bottom here I added the lines, if local equals playerx plus 4, then go to scroll right, and if local equals playerx minus 4, then go to scroll left. And basically all it's doing is copying the background scenery, which I had to widen by about 2 blocks on either side, and I had to recenter it basically 1 block over. So instead of the scenery being referenced at 0, 0, it's referenced at 1, 0. And the sprite itself is still only 80 by 25 wide, but the MZM itself extends 1 block on either side of the sprite that's off screen that you can't see. So what it does is copies a block of basically 1 column of characters from, if it's scrolling left, it copies them from the left edge of the block to the right edge of the block, and then scrolls the whole block to the left once. And then it copies the end of the block again in the same manner. And that is so that if you stop and go the other direction before you get to scroll again, if you go from scrolling left to scrolling right, that's so that it doesn't mess up the edge of the scenery. Basically, you need it to always be, you need that last operation to always be copying the blocks one, left edge to the right edge. I'm not explaining that very well. I'll show you what it looks like real quick. So if you don't have this line in here, and you go to this, now if you look over at the right edge of the screen, if I change direction and then go back, it puts, it messes up the edge of the scene. You see how it basically copied what's right under the player, the mountain there. It basically copied that block twice. So what you have to do is you have to make sure you have that same copy command at the end, at the beginning and the end of moving the entire block over. So after it moves the entire block over, it resets local to playerx again, and then goes back to the top of the loop and starts over. So anytime the player moves a distance of 4 in either direction, it scrolls either right or left. And I could change that. I could have it just be 2 and it would scroll faster. And it doesn't look too bad, but I kind of like, oh, and then you want to not allow the player to move past where the board stops moving, because the background will continue to scroll and it'll look stupid. Unless you add programming there to allow the background scenery to stop moving when the foreground scenery stops. So you could change this to, let's try like one scroll for every 6 blocks the player moves. So it's a much slower scrolling background. That doesn't look too bad. This would actually look better if you were using a large character sprite and the sprite was moving 2 blocks every animation cycle. If the foreground was scrolling faster, then the background could scroll a little faster too, and it would look more, the animation would look a little smoother. So yeah, that's all that is. So this is in my game Servo that I'm creating, and it's I'm going to show you how I'm using the program that I showed you earlier in a fully sprite-based game. So we still have the scroll view robot that controls scrolling, but instead of following the player, it's following a sprite. So this is the loop here, and so this line right here is a large expression that basically tracks whether the player is outside a certain boundary, and if it is, it does not scroll, so that way the the game doesn't continue to scroll when the player has gone too far towards the edge of the board, and that'll cause problems because it will basically stop drawing the sprite, and it'll just look wonky. So it's just a very large expression that says, you know, if the player sprite, which I just named the counter player to represent the player sprite. So if x is greater than 57 or less than board width minus 64, it's a complicated expression, but basically it won't allow scrolling all the way to the edge of the board. So you need to add this line here, scroll view position, and it needs to be referenced to the player sprite, and then include the math for the screen position. And then the rest of it's pretty much the same. Instead of player X and player Y, it's going to be this player sprites X and Y. Other than that, as you can see, it's pretty much the same program, and so it just follows the player sprite around instead of an actual player object. And the rest of this program down here is for making the position of the screen actually move around a little bit depending on if the player is aiming a gun. I'll show you what that looks like real quick. Let's just go into level 1. So so if he's aiming a gun, it basically moves the screen around depending on where he's aiming at. So it just allows a little bit more a view of the surroundings to make it easier to target an enemy. Yeah, that's all that is. When you let go of the button, it centers the view back on the player.